Hello friends, I Professor Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head Control System Engineering. Friends, as far as our today's session is concerned, so we will try to learn a very important technique which is used to tabulate the overall transfer function of this given control system, whose name is nothing but what? The signal flow graph technique. So quickly we will go through the objective for today's session. So as you can see, such type of control system we are having with us, which is represented is in terms of this SFG, that is nothing but what? The signal flow graph. So by means of this Mason's gain formula, we need to determine the overall transfer function of this control system, right? So first of all, let us quickly go through this Mason's gain formula, which is used to determine the overall transfer function of that system. So this is how our control system will look like. So as far as this control system is concerned, so the Mason's gain formula equals to, it is 1 over delta followed by summation of pi into delta, right? So this is the straightforward formula which is used to determine the overall transfer function of that system. So in this statement, as you can see, first of all we need to understand the significance of this term, that is nothing but what? The system determinant, or we can call it as a delta, right? So we have certain standard relation in order to determine this system relation, in order to determine this system determinant. So for that purpose we need to collect a finite number of parameters belongs to this signal flow graph representation technique, right? So here delta equals to what? Here I will write delta equals to 1 minus, within this first parenthesis I will write the notations like this: P11 plus P21 plus P31, right? Then after that, along with this addition sign, plus within that second parenthesis the notations are like this: the P21 plus P22 plus P32. Within that last parenthesis, along with this negative sign, here I will write P31 plus P32 plus P33. A number of terms we can have within that parenthesis. So as far as this Mason's gain formula is concerned, I will put this formula within this rectangular box. So there are three basic parameters within that Mason's gain formula. It is 1 over delta. In this way, that delta is to be declared, that is nothing but what? System determinant. In order to decide the system determinant, we need to collect all the terms which are being written within these three brackets, right? As far as these first two parentheses are concerned, so which terms are being written? P11, P21, P31. So here we will come to know what this P11 stands for, P21 stands for, P31 stands for. First parenthesis. Within that second parenthesis, the terms are nothing but what? P21, P22 and P32. Within that third parenthesis, P31, P32 and P33. So one by one we will come to know, right? So as far as this first parenthesis is concerned, in order to decide the desired value of that system determinant, so as you can see, this P11, P21, P31 along with this addition sign, so this whole term stands for what it is, that can be called it is as a summation of individual loop gain of the signal flow graph representation. Means this P11, that can be called it is as a first individual loop. P stands for what? The individual loop, first individual loop. P21 stands for second individual loop. P31 stands for what? The third individual loop. So in this way, the individual loops are to be defined in the signal flow graph representation. First individual loop, second individual loop and third individual loop, right? And we need to add their individual gains within that first parenthesis to determine the system determinant. So from sake of observation, we need to observe how many individual loops are there in the signal flow graph representation, right? So this is all about this first parenthesis, 1 minus P11, P21 plus P31. So n number of individual loops we can have within that signal flow graph representation. So what we need to do, we need to add their gains within that first parenthesis, right? So along with this plus sign, as far as the second parenthesis is concerned, so what is written within that second parenthesis, or what are the relevant terms which are present within that second parenthesis? P21, P22 and P32. So what these are? That can be called it as a first two non-touching loops. P21 is nothing but what? It is the gain product of first two non-touching loops. P22, that can be called it as a gain product of second two non-touching loops. Similarly, the gain product of third two non-touching loops. First of all, we need to understand what do you mean by this non-touching loops. So once we had observed, keep suppose there are n number of loops, right? So out of that n number of loops, what we need to do, we need to find out first two non-touching loops, second two non-touching loop, and third two non-touching loops. Non-touching in the sense they are not sharing the similar elements, or they are not sharing the similar nodes. At that time we can call it as a non-touching loop. So their gain product is nothing but what? P21. The gain product of first two non-touching loops, the gain product of second two non-touching loop, and the gain product of third two non-touching loops. So in this way these iterations are to be written. Now this is all about the second parenthesis of this system determinant delta, right? Now as far as this third parenthesis is concerned, so within that third parenthesis, which is quite similar to the second parenthesis, right? So what it is? P31, P32 and P33. So P31 is nothing but what? The gain product of first three non-touching loops, right? The gain product of second three non-touching loops, the gain product of third three non-touching loops, the gain product of n number of three non-touching loops. So in this way, all these things are being iterated within this statement, that is nothing but what? 1 over delta, to decide the desired value of this system determinant delta, right? So basically there are three parameters in this Mason's gain formula. Actually this method was invented by American scientist whose name is nothing but what? Samuel Mason, in the years of 1950s. So on behalf of his invention, the name given to this formula is nothing but what? The Mason's gain formula, which is used to tabulate the overall transfer function of this signal flow graph representation technique, right? Now the second parameter is nothing but what? P suffix I and delta suffix I along with the summation sign, right? So now question arises in our mind, for how many number of times that summation sign will get iterated. So ith number of time that summation sign will get iterated. So what this P suffix I, right? So this P suffix I is nothing but what? The number of, or the ith number of forward paths, right? Which are present in the signal flow graph representation, right? Pi stands for what? The total number of forward paths which are present within this signal flow graph representation. So forward path means that is nothing but what? Through that path we can complete our journey from input to the output. This is the desired path which is present in between these two parameters of the signal flow graph representation. Once we start our journey from this R, so forward path, or through that path we can conclude, or we can end our journey at this C, right? In between, whatever the elements we have with us, the product of that element is nothing but what? The gain of that forward path, right? Now as you can see, for sake of this moment, in between R and C, the first forward path is nothing but what? This horizontal line, right? This horizontal line which is present in between R and C. So in between R and C there are how many elements we are having with us? Like elements are nothing but what? This G suffix 1, G2, G3 and G4. There are total 6 elements. Out of that 6 element, the gain of this forward path which is present in between these two loops is nothing but what? 1. Similarly, the gain of this forward path which is present in between these two nodes is nothing but what? Again it is 1. So out of that 6 element, there are 2 unity gain elements. So the remaining elements are nothing but what? G1 to G4. So G1, G2, G3, G4, that itself is a forward path number 1. So in this way we need to determine how many number of forward paths we are having with us. And as far as this delta I is concerned, so laterally I will try to tell you, this delta again it will get iterated for ith number of time, right? So number of forward paths equals to the number of deltas that we need to consider in that Mason's gain formula. If there are two forward paths, so there are two delta, delta 1 and delta 2. So delta 1 is nothing but what? 1 minus summation of all loop gain which will not touches to that forward path number 1. Similarly, delta 2 belongs to summation of all loop gains which will not touches to the forward path number 2. Means it is the special part of this signal flow graph representation that we need to define, which will not touches to the desired forward path, whether it is 1, 2, 3 or n number of path. So in this way, this Mason's gain formula is to be used to determine the overall transfer function of this signal flow graph representation technique. Now in that lateral part, now we will try to tabulate the transfer function of the signal flow graph representation, right? So for that purpose, what we need to do here, we need to observe 3 or 4 parameters of that signal flow graph representation. Means there are certain rules by which, or by adopting that rules, we can determine the overall transfer function of that signal flow graph representation. So these rules are nothing but what? First step, or the first in that solution, in that first step we need to count how many number of forward paths are there, right? So we are supposed to determine these PIs. PI stands for what? Ith number of forward paths we are having with us, right? In that second step we need to determine, or in order to tabulate the system determinant, right? We need to determine these 3 parentheses. As far as this first parenthesis is concerned, so what is written within that first parenthesis? It is the gain of all individual loop, right? So we need to determine how many number of individual loops we are having with us. Without that, it is not possible for we people to tabulate the statement which is written within that first parenthesis. What it is the summation of all individual loop gains. So in that second step, we need to determine number of loops, right? In that third step, once we had tabulated there are n number of loops, so out of that n number of loops, we need to determine the 2 non-touching loops and 3 non-touching loops. Means in that third step, we need to determine 2 non-touching loops and 3 non-touching. This is the generalized step to determine the Mason's gain formula, right? And in that fourth step, with the help of this Mason's gain formula, we need to determine its transfer function. So these are the 4 basic steps which involves into this Mason's gain formula in case of the signal flow graph representation technique. So one by one we will try to follow this step. So for sake of moment, I will grab all those things. So one more time, Mason's gain formula which is used to determine the transfer function, here I will write, will be what? It is 1 over delta into summation of Pi into delta I, where this delta fellow is nothing but what? Delta equals to 1 minus summation of all individual loop gain. First individual loop gain P11 plus second individual loop gain P21 plus third individual loop gain P31 plus again within that parenthesis the gain product of first 2 non-touching loop, second 2 non-touching loop, like this. So that can be called as a P21 here, P11, here it will become P12 and here it will become P13. First individual loop gain, the second individual loop gain, third individual loop gain, P21 plus P22 plus P32. What it means? It is the summation of first the product of first 2 loop gain, product of second 2 non-touching loops and the product of third 2 non-touching loops as far as the third parenthesis is concerned. So plus it is P31, right? It is that can be called as a gain product of first three non-touching loop, P32 gain product of second three non-touching loop, and P33 the gain product of third three non-touching loops, right? So in this way, this delta has to be declared. Okay friends, so in that lateral part, first of all we need to determine how many number of individual loops we are having with us, right? Loop, the basic definition of that loop means that is nothing but what, once we had started our journey at that particular node, so we should terminate our journey to that same node. So that is the concept of loop, what we can say that from this signal flow graph representation point of view. So as you can see, that can be called it as the first loop, right? Similarly, how it is to be represented here individually, I will try to show this loop, or that can be called it as a P11. So see, in between these two nodes like this, and this is the feedback element whose gain is nothing but what, minus h1, and the gain of forward path is nothing but what, here g4. So this will be first loop, right? So here P11 equals to what? P11 equals to, how to tabulate this P11? We need to multiply these two elements. So as a result of multiplication, it will become minus G4 times of H1 will be P11, right? Similarly, here I will try to show the second loop, right? So the second loop belongs to H2 and third loop belongs to H3. Then we will find whether we are having any further loop or not. So here I will try to show which consists of these three nodes. Here gain is G2, here the gain of forward path is G3, and its feedback element is nothing but what, minus H2. So here P12, right? The second individual loop gain will what? These three elements are being multiplied, so it will become minus G2 G3 times of H2 third, right? So third loop will be what, belongs to this H3. How it is to be shown? Again we are having these three elements, and this is nothing but what, H3. The forward path gains are G1 G2. So here P13, the third individual loop gain will become, these three elements are being multiplied, minus G1 G2 times of H3. Now one more loop we are having with us, right? That loop consists of this forward path G5. When we are coming across to this node, with the help of this feedback element, we will come across to this particular node, and from this node we can terminate our journey to the same point from which we had started. So how this loop will look like, here I will draw. This forward path is nothing but what, G5, right? Then through this feedback element we are coming across this, that is nothing but what, minus H1, and from here with the help of this minus H2 we will come across to that point from where we had started. So that can be called it as a P14, fourth individual loop gain, and its gain will be what, how many forward paths it consists of? It consists of only one forward path and two feedback paths. So its overall gain will become minus of G5 times of H1 H2, right? So as we are having these four loops, 1, 2, 3 and 4, right? So in this way this first term is to be tabulated. After that what we need to do, simply we need to add these four individual loop gain to determine the first parenthesis of the system determinant delta. Then similarly in that next step we need to determine the parameters which are being written within that second parenthesis. What these are, as I told you earlier, these terms are nothing but what, the gain product of any two non-touching loops, right? So when it is required to decide in that second step, this will be the first step, or in that second step we need to declare this P21 as well as P22, or that is nothing but what, P32. So one by one we will try to declare. So P21 stands for what? It is the gain product of first two non-touching loops. So from sake of observation, we need to find out ki there are how many number of non-touching loops we are having with us, right? So when we compare the loop number 1 and loop number 2, so obviously this loop number 1 and loop number 2, as they are sharing the similar node, so we cannot say that these two are the non-touching loop. But when we compare the first loop and the third loop, right? So at that time we will come to know as they are not sharing the similar elements as well as they are not sharing the similar nodes. So these two loops can be called it as a non-touching loops, because the gain of that first loop is nothing but what, minus g4 times of h1. The gain of that third loop is what here, g minus g1 g2 times of h3. It has nothing to do with the similar node, because this portion belongs to loop number 1 and this portion belongs to loop number 3, as they are not sharing the similar elements. So we can say that the first term which is written within that second parenthesis, that is nothing but what, p21, right? The first two non-touching loops, we will come to know ki this p11 and p13, these are nothing but what, the first two non-touching loops. So their gain product itself is a p21. So here I will write p21 equals to p11 into p13, right? Now apart from these two non-touching loops, we don't have this p22 as well as p32. The second two non-touching loops we don't have. The third two non-touching loops also we don't have. So we are having only one parameter as far as the second parenthesis is concerned. So that is nothing but what, p21, right? The first two non-touching loops as far as p11, p12, p13, p14, these are concerned, these are nothing but what, the individual loop gain. So here it will become, these two terms are being multiplied, p11 and p13, as a result of multiplication, minus minus it will become plus. So here I will write in this ascending order g1 g2 into g4 followed by their feedback elements are nothing but what, h1 and h3. So this whole term that can be called it as a p21. Now as far as the third parenthesis is concerned, so we don't have any three non-touching loops. Total number of loops we are having 4. So out of that 4, we don't have any three non-touching loops, because either they are sharing the similar element or either they are sharing the similar nodes. So we are coming on to this conclusion ki we don't have any three non-touching loops. So this term will become 0, right? This entire term will become 0, right? Now in that next step, what we need to do, so in this way the first parameter is to be tabulated. So here I will write delta, what, delta equals to what, 1 minus p11, p12, p13 plus p14. We need to add all these individual loop gains. So again it will minus minus it will become plus. So directly I will write 1 plus g4 times of h1 plus the second loop gain will be what, plus g2 into g3 times of h2. Third individual loop gain will be what, g1 g2 into h3. Along with this minus sign, minus minus it will become plus. So it will become g1 g2 into h3 plus the fourth loop gain is nothing but what, minus g5 h1 h2, right? Here it will become h1 is also minus, h2 is also minus, so minus minus it will become plus. So it will become plus g5 into h1 h2. So here it will become minus, as it is multiplied with this minus sign. So it will become minus g5 times of h1 h2. This whole term that can be called it is as a delta, right? So 1 over delta, as far as this numerator is concerned, so within that numerator we need to determine this pi into delta I. So here I will write pi stands for what, the number of forward paths. So how many number of forward paths we are having with us? Here there are 2 forward paths, right? First forward path is nothing but what, this horizontal line from R to C, and its gain is nothing but what, 6 elements are there. Out of that 6 elements, 2 are the unity gain elements. So the remaining elements are G1, G2, G3 and G4, right? The second forward path is nothing but what, once we start our journey with this R, when we are coming across this particular node belongs to G1, then from this G1 with the help of this forward path whose gain is nothing but what, G5, again we can terminate our journey at this C. So there are 2 forward paths. Out of that 2 forward path, the gain of that first forward path is nothing but what, this G1, G2, G3 into G4, and the gain of second forward path is nothing but what? G1 into G5, and accordingly here I will write, we are having two deltas, delta 1 and delta 2. So delta 1 equals to what? 1 minus summation of all individual loop gains which will not touches to the forward path number 1. We are having 4 loops, and all these 4 loops will somehow, they will try to touch the first forward path, which exactly equals to G1, G2, G3 and G4. So delta 1 equals to what? 1 minus 0, means again it will become what? Similarly delta 2 equals to what? 1 minus summation of all individual loop gains which will not touches to the forward path number 2, right? We are having 4 loops. Out of that 4 loop, we don't have such type of loop which will not touches to the forward path number 2. So again delta 2 equals to what? It will become 1 minus 0, it will become 1, right? So according to our Mason's gain formula, transfer function will become what? Here I will write, transfer function equals to Pi into delta I. For how many times this summation cycle will get iterated? Here we are having 2 forward paths, so P1 is nothing but what? Here I will write G1, G2, G3 into G4 into delta 1. Delta 1 equals to 1, so no need to write plus. P2 is nothing but what? G1 into G5. This will be the numerator of this transfer function, right? Here I will write transfer function equals to, right? And as far as its denominator is concerned, so within that denominator, we need to write this whole term belongs to this delta. So what it indicates? It indicates 1 minus summation of all individual loop gains, right? Plus, as far as this P21 is concerned, P21 is nothing but what? Here it is to be tabulated. It is the gain product of these two non-touching loops, first loop and third loop. So we need to write this term in this delta equation. So again it will become what? Plus G1, G2 into G4 followed by H1, H3. Somehow we need to complete this delta, right? Because delta equals to 1 minus all summation of all individual loop gain plus the gain product of any two non-touching loops minus the gain product of any 3 non-touching loops. So this is how this delta we need to write. So here delta will become what? 1 plus G1 into H1 plus G2, G3 into H2 plus G1, G2, H3 minus G5, H1, H2 plus the summation of first two non-touching loop. Their statement, overall statement is G1, G2, G4 into H1, H3. So this whole term can be called it as a transfer function of this signal flow graph representation technique with the help of this Mason's gain formula, right? According to this Mason's gain formula, 3 parameters we need to determine. These 3 parameters are nothing but what? First parameter is how many number of forward paths we are having with us. Along with these PIs, we need to determine the delta I, delta 1, delta 2, delta 3. What it stands for? It will be 1 minus summation of all individual loop gain which will not touches to forward path number 1, forward path number 2, forward path number 3 or ith number of forward path, right? In that second step, we need to determine this fellow called it is as a delta. So to decide the desired value of this system determinant, we need to determine all individual loop gains, like first individual loop gain, the second individual loop gain which is somewhere which is written on that board, third individual loop gain, fourth individual loop gain, right? And their summation of all individual loop gain will give you the first parenthesis. The second parenthesis stands for what? That will be the gain product of any two non-touching loops. At which moment we can call it as these 2 or these 3 loops are non-touching loops when they are not sharing the similar nodes or when they are not sharing the similar elements, right? So in that third step, we need to write the desired statement for this Mason's gain formula, right? So in this way, the overall transfer function of the signal flow graph representation is to be tabulated with the help of this Mason's gain formula. Thank you.